much you're going to have an example of every kind, or at least almost every kind, and they're asking you to identify which is which. If you know the general form, you should have no trouble with that. You have done a lot of the different kinds of reactions already, and it's something that you should be pretty comfortable with. I will say this again, I know I've said it in class several times, make sure you know what happens in each of the kinds of decomposition. What do metal hydroxides break into? What do metal carbonates break into? What do metal chlorates break into? What do acids break into? What do simple binary compounds break into? There are set patterns for those, and recognizing those patterns is going to be very helpful to you when you're trying to identify synthesis reactions that happen in reverse. I guarantee you, you will need that on your honors page. In the second half of the questions, 3, 4, 5, and 6, where you will be balancing equations from word equations, doing reaction prediction, and telling me what kind of a reaction it is. Hint, 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 that explains a lot of your honors page. One whole side of the honors page, if you're watching these in a year where we actually take the full test instead of the condensed version that we happen to be taking this year. Some other things on the honors page, well, I'll talk about those in a little bit. Okay, test hint, jumping down to number 14, 14, 15, and 16, and almost, well, 17 similar. What is produced in one of the 6 kinds of decomposition reactions? Okay, so you need to know that metal hydroxides are going to produce water and a metal oxide. Metal chlorates are going to produce a metal chloride, binary compound, and oxygen gas. Metal carbonates, like sodium carbonate, are going to produce a metal oxide and carbon dioxide. Acids are going to produce a non-metal oxide and water. Basic binary compounds are going to break down into their elemental form. There's a pattern for all of those. Look to the polyatomic ion. Remember that polyatomic ion is covalently bonded and then it's attached to a metal to make an ionic compound. That polyatomic ion with that weaker bond is going to break apart first. So see what you can pull out of there. Hydroxides, water, carbonates, carbon dioxide, and go from there. Study this part extensively. You need to be very fluent in this. Make sure you look at the page of notes that I have on all these different kinds of decomposition reactions and make sure you know those. Moving on to test hint number 17, what happens in a specific type of replacement reaction? Okay, there's 4 kinds of replacement reactions, and this question is going to be about one of the 4 kinds. We can have metals kicking the hydrogen out of an acid. Hydrogen's kind of in an acid is acting like a column 1 metal, trying to be ionic, but it really isn't. A metal can come along and kick the hydrogen out of an acid. You saw that in the activity series lab. We physically did this. An active metal can kick the hydrogen out of water. Think of water as H plus and OH minus. It's really hydronium. For anybody watching this that's had a little bit more chemistry, you know it's H3O plus. But for right now, we'll think of it as HOH. And we can have an active metal coming along and replacing the hydrogen in water, grabbing onto that OH ion, making a hydroxide, kicking the hydrogen gas out. You loved it when we did this as a demo. We had lithium, sodium, and potassium in water. We saw video of sodium chunks being thrown into a pond and the flame and the loud crashes and bangs. You saw cesium and rubidium in an online video. And on the laser disc, and you really wanted me to do that in class, which of course I can't because we can't get that stuff. But you can have a metal replacing the hydrogen in water, replacing hydrogen in acid, replacing hydrogen in water. You can have a metal replacing a metal in a compound and taking its place, like our iron and copper sulfate lab. You've done that yourself as well. And you saw that in the activity series lab. And finally, we can have a new halogen coming along, fluorine, chlorine, bromine, or iodine, and kicking out a halogen from another compound. I've got a lot of examples of this in the notes. It's pretty straightforward. If you look at the labs that you've been doing, see that you've been writing the balanced equations for those kinds of reactions quite a bit. Which brings us to number 18, 19, and 20, the general types of products possible in double replacement reactions. In 18, 19, and 20, again, you'll have some specific reactions that are being referred to. And what are some of the products? Well, a solid that doesn't dissolve and comes out of solution, that's called a precipitate. Anytime you've mixed drops of things together and gotten cloudiness, you've been forming precipitates. There's going to be an awesome, dramatic, and exciting precipitate example in a lab. We're going to do it in the next chapter. You're going to love it. I promise. True. Drama and excitement. So you get a precipitate out. An acid and a base can come together and make a salt and liquid water. Liquid water is one of the products of decomposition that is common. Sometimes two components can change partners and the gas comes out. Okay? Excuse me, two chemical compounds can do that and we could get a gas produced. So all of those are evidence of a double displacement reaction happening. Number 20 is a question that actually goes back to a single replacement reaction. Rewind a little bit, drag the cursor back, and listen to my suggestions for, a single displacement, again, for number 20. 21, identify the products of a specific composition reaction. Well, composition involves elements or simple compounds coming together to make something more involved. If you know the 6 main kinds of decomposition, you're going to recognize this one right away. See if you can make one of the polyatomic ions, hydroxide, carbonate, chlorate, out of, or sulfate even, nitrate, phosphate, out of the substances being mentioned in this problem. You'll get this one no problem at all if you know your 6 kinds of decomposition, because this will be that in reverse. Test hint number 22, what is produced in one of the 6 kinds of decomposition reaction? Well, that's going to be just the opposite of the one we just went over. Again, you need to know the types. So we've had, what, 3 or 4 questions like this already. You must know the 6 kinds of decomposition reactions and what happens in each. Study up on that. Test hint number 23. The general types of products possible in a replacement reaction. So 23 would be one of the kinds of single replacement reaction. Know the 4 types. A metal replacing another metal. A metal replacing hydrogen in an acid or water. Or a halogen replacing another halogen. 24, the general types of products in double displacement reactions. Well, how many times do we have to go over the same thing? In double displacement reactions, you tend to get precipitates. You could have a reversible reaction where you end up with 2 ionic compounds that are still soluble in water instead of getting one that's insoluble or one that's a liquid or one that's a gas. That would be a reversible reaction. Sometimes you see that. But this will be a question about the basic kinds of substances formed in a double displacement reaction. It'll give it in context an example of specific compounds that would be coming together. So you get the names of the 2 reactants, and the answer choices are in the form of chemical formulas of the products. Okay? So you have to kind of write some and balance some equations as you go along throughout the test. Excuse me. Test hint 25 and 26, how the activity series works. You know, I think I asked you this in one of the Moodle questions. Excuse me. What is the activity series? Well, the activity series is simply a list of the elements from most reactive to least reactive. And that's based on experiment. It's also called the electromotive series because there is actually a transfer of electrons and electric current that happens along with this, which we would get to in electrochemistry. But for our purposes, this is a listing of elements from most reactive to least. We have a listing for metals, and it includes hydrogen, just like you did in your activity series